Ever wondered how India's DRDO railgun works? It's a piece of technology that's set to revolutionize the future of warfare. This isn't just any ordinary weapon. The DRDO railgun is a cutting-edge piece of military hardware developed by the Defense Research and Development Organization, or DRDO, in India. It's a game-changer, set to redefine the boundaries of modern warfare. At its core, the DRDO railgun is an electromagnetic marvel using the power of electromagnetic forces to accelerate projectiles at hypersonic speeds. Imagine this: a projectile being propelled at speeds exceeding Mach 6. That's faster than any fighter jet we know of, and it's all thanks to the power of electromagnetism. The railgun isn't just about raw speed though. It's a system designed with precision and versatility in mind. With a range reportedly over 100 kilometers, it's a long-range weapon capable of delivering a variety of payloads with pinpoint accuracy. Whether it's kinetic energy penetrators or high-explosive rounds, this railgun can handle them all. But how does it achieve this remarkable feat? The answer lies in its unique configuration, which consists of two parallel rails connected by an electrical power source. This setup generates a powerful electromagnetic field which accelerates the projectile placed between the rails. Of course, such a system generates immense heat, requiring a sophisticated cooling system to prevent overheating and damage. And powering this railgun, that's a high-power electrical generator, another testament to the DRDO's innovative approach. It's not just about the hardware though. The guidance system ensures accurate targeting and trajectory control, making the railgun a reliable and efficient weapon system. However, it's important to note that the DRDO railgun is still being developed and tested. The exact timeline for its induction into the Indian military isn't publicly known. But one thing's for sure, the potential applications for this technology are vast, from naval warfare to land-based defense, and even potentially space-based defense. The DRDO railgun is set to make a significant impact. Let's delve deeper into how this intriguing piece of technology actually works. At the heart of the DRDO railgun is the principle of electromagnetic propulsion. This is a game-changing technology that harnesses the power of electromagnetic forces, an invisible yet immensely powerful force that permeates the universe. Let's break this down. Electromagnetic propulsion operates on the principle of Lorentz force, a concept in physics named after the Dutch scientist Hendrik Lorentz. In simple terms, when an electric current is passed through a magnetic field, it experiences a force. This force, the Lorentz force, can be harnessed to create motion. Imagine two parallel rails connected by an electrical power source. When a projectile is placed between these rails, a powerful electromagnetic field is generated. This field interacts with the current in the rails, creating the Lorentz force that propels the projectile forward. The stronger the current and the magnetic field, the greater the force and the faster the projectile can be accelerated. Now, this isn't your everyday kind of speed. We're talking hypersonic velocities here. The DRDO railgun is reportedly capable of accelerating projectiles to speeds exceeding Mach 6. To put that into perspective, that's a staggering 7,200 kilometers per hour or around 4,470 miles per hour, faster than any traditional chemical propellant could ever hope to achieve. This incredible speed is not just about breaking records. It opens up a plethora of tactical advantages. For one, it significantly extends the range of the weapon, reportedly to over 100 kilometers. Furthermore, the sheer velocity of the projectile enhances its destructive power, even without any explosive payload. The kinetic energy alone can cause devastating damage, but it's not all about brute force. The DRDO railgun also incorporates sophisticated guidance systems for accurate targeting and trajectory control, making it a precision instrument of power projection. Now that you understand how the railgun propels projectiles, let's look at the railgun's configuration. The railgun's design is as fascinating as the technology that powers it. The railgun configuration is cleverly straightforward, yet intriguingly complex. It consists of two parallel rails acting as the heart of the system, connected by an electrical power source. These rails aren't just any ordinary rails. They are the conduits for the immense electrical power that propels the projectile. Imagine the rails as two separate highways for electrons. When the power source is activated, it generates a powerful electromagnetic field that fills the space between these rails. Now, picture the projectile. It sits snugly between these two parallel rails, waiting to be hurled into space at hypersonic speeds. The role of the electrical power source is crucial. It's the engine that drives this impressive machine. The greater the power supplied, the stronger the electromagnetic field that's generated. This, in turn, translates to a higher velocity for the projectile. But this power isn't just about brute force. It's about precision and control. The electrical power source must be regulated carefully to ensure the projectile is launched with the right amount of force and in the right direction. The placement of the projectile is another key aspect of the railgun's configuration. The projectile is introduced between the rails, acting as a bridge for the electrical circuit. The moment the circuit is complete, the electromagnetic forces come into play, accelerating the projectile along the axis of the rails. The beauty of this design lies in its simplicity. There are no complex moving parts, no need for chemical propellants, just pure, raw, electromagnetic power. All these elements work together in perfect harmony to create a weapon system that is not only powerful, but also incredibly precise. The railgun's configuration is a testament to the ingenuity and innovation of its designers, pushing the boundaries of what's possible in defense technology. Next, we'll discuss the performance characteristics of the railgun. The DRDO railgun's performance characteristics are truly impressive. Let's dive into some of these key features. First and foremost, the velocity. The DRDO railgun is designed to accelerate projectiles to hypersonic speeds. We're talking about speeds that reportedly exceed Mach 6. That's around 7,200 kilometers per hour, or to put it in another perspective, 4,470 miles per hour. Now let's talk about range and accuracy. The railgun is expected to have a range of over 100 kilometers. That's a distance longer than 62 miles. As for accuracy, the railgun is designed with precision in mind. Although the exact figures for range and accuracy have not been publicly disclosed, the emphasis on precision suggests a high degree of accuracy in hitting targets. Powering such a beast is no small feat. The railgun requires a significant amount of electrical power to operate. To meet this demand, the DRDO has reportedly developed a high-power electrical generator. This generator is key to the railgun's operation, providing the electrical power needed to generate the powerful electromagnetic field that propels the projectile. But with great power comes great heat. The railgun generates immense heat during operation. This heat, if not managed, can cause damage to the system. To prevent this, a sophisticated cooling system is in place. This cooling system helps to dissipate the heat generated during operation, ensuring the railgun can operate without overheating. In summary, the DRDO railgun offers impressive performance characteristics. Its velocity and range capabilities, combined with the power source and cooling system, make it a formidable piece of technology. These features could potentially revolutionize the way we think about projectile weaponry, ushering in a new era of defense technology. Now that we've covered the performance, let's discuss the materials used in the railgun's construction. The materials that make up the DRDO railgun are as crucial as the technology itself. The railgun's key components, including the two parallel rails, are crafted from advanced materials like high-strength steel or cutting-edge composites. But why is this important? Well, these materials are chosen for their ability to withstand the immense stresses and heat generated during operation. Just imagine a projectile being accelerated to speeds exceeding Mach 6. The forces at play are truly colossal. To put it simply, the railgun is like a high-speed express train on a microscopic scale, and it needs tracks that can handle the heat and pressure. Moreover, these materials need to be durable enough to survive repeated use, ensuring the railgun's longevity. So the choice of materials is, in fact, a delicate balancing act between strength, heat resistance, and durability. Finally, let's look at the railgun's development status and potential future applications. The DRDO railgun is still in the development phase, but its potential applications are vast. With ongoing testing and trials, the exact timeline for its induction into the Indian military remains a closely guarded secret. But let's delve into the future, shall we? Imagine a weapon system with potential applications in various domains such as naval warfare, land-based defense, and even space-based defense. Quite a leap from traditional artillery, isn't it? The railgun's electromagnetic propulsion offers a multitude of advantages over traditional chemical propellants. We're talking about higher muzzle velocities, longer ranges, and potentially lower operating costs. This isn't just about faster and farther. It's about transforming the face of warfare. As we move forward, the DRDO railgun, with its sophisticated technology, promises to redefine the boundaries of combat. It's not just a weapon, it's a symbol of a rapidly evolving defense landscape. The DRDO railgun, with its sophisticated technology and potential applications, is truly a game changer in the realm of defense.